Okay, untuk our 3 ni kita dah masuk salt hydrolysis and a little bit of buffer. Okay, look at this question number 15 where hydrolysis of the write the hydrolysis equation for this salt. The first salt is NaCN. So this NaCN is come from the sodium hydroxide. Okay, it is separated into Na plus and Cn minus, where NaOH react with the HCN, producing NaCN and H2O. Okay, this one like this. Okay, so this reaction is between strong base and weak acid. So if strong base, the conjugate that produce is the weak conjugate. Okay, now this one is strong base, so it will be weak conjugate acid. And if Cn minus, it's come from the weak acid, so it will produce strong conjugate base. So the species that become strong conjugate will hydrolyze water. That means this salt where the ion Cn minus ion can dissociate H2O. Okay, let's see what happens if the Cn minus react with water. So it will produce, okay, so this species will break to H plus and OH minus. So H plus we love to combine with the Cn minus because it is positive and this is negative. So it will produce HCN and leaving OH minus. If this reaction, if this salt dissociate water or hydrolyze water, it will produce OH minus. That means this solution is basic solution. If basic solution, that is mean that this salt is NaCN is a basic salt. Okay, what about this one? So let's dissociate this acid. It's become N2H5 plus and Cl minus. So N2H5 plus come from N2H4. Cl minus is come from the reaction of HCl. That means the reaction of strong acid with the N2H4 weak base will produce this salt. Now let's dissociate the salt form. It is N2H5 and Cl minus. So which of the species will hydrolyze water? To determine which species hydrolyze water, let's identify. This is weak base, so it will form strong conjugate acid. This is strong acid, HCl strong acid, and it will form Cl minus as weak conjugate base. So the species that will hydrolyze water is N2H5. So take the N2H5 plus react with water H2O. So it will break to H plus and OH minus. So the species that will go to the water is the H plus. Dia akan keluar. Dia akan menjadi N2H4 plus H3O plus. Okay, so it will form acidic solution. Therefore, this salt is acidic salt. Okay, N2H5Cl is acidic salt. What about NaCl? NaCl is come from Na plus and Cl minus. So it comes from NaOH as a strong base, so it will form weak conjugate acid. Cl minus is come from HCl, which is strong acid. So Cl minus will become weak conjugate base. Since both of them are weak, both of them cannot hydrolyze water like this. Since they cannot hydrolyze water, the concentration of H plus or extra OH minus does not produce. That means it is neutral salt. Question number 16. What is buffer? Is the solution that has ability to maintain its pH when small amount of strong acid and strong base is added. That means if we add strong acid or small amount of strong base to the buffer solution, the pH does not change too much. So it is a buffer solution. For question 16b, we need to calculate the ratio of the concentration ammonia to ammonium chloride needed to form a buffer solution. Okay, in order to calculate buffer, we need to use the Henderson-Hasselbalch equation where POH equal to PKB log salt over base, weak base. So why we use this kind of Henderson-Hasselbalch? Because our solution, our buffer solution is basic buffer solution. Okay, basic buffer solution. What is basic buffer solution? It is made up of weak base and its salt, which is its conjugate acid. So given the pH of the buffer is 8.3, so pH is equal to negative log concentration H plus. However, this buffer doesn't have the concentration of H plus. So since the pH is 8.3, we can find the POH where 14 minus 8.3. So 14 minus 8.3, the POH is 5.7. So we can substitute into the POH. And the KB given is negative log 1.8 exponent negative 5 plus log salt over weak base. So kita boleh selesaikan 5.7 plus log 1.8 exponent negative 5 and then equal to log concentration salt over concentration of weak base. Okay, then you will get this one as an answer is log NH4 plus over concentration of ammonia. So you bring this one and it will be anti-log answer. So it is concentration of NH4 plus over concentration of ammonia, which is 0.9. Okay, since we want the concentration of ammonia over concentration of the salt, then we need to invert this 0.9, which is 1 over 0.9 is equal to 0.11. Okay, so that's all for question number 16.